Hello friends, welcome to HadoopBigDataTutorial.com, powered by Wisdom Trainings. Right. So in this module, in this video, we'll be talking about reduce joins. Right. So I'll take you through that. Okay. So here is my reduce joins. So we have already talked about map joins in some other videos, in the videos that you'll find in the modules. Okay, in the advanced map reduce section. But I'll just brush up the map side join as well. And there are two types of joins, that is map side joins and reduce side joins. We have spoken about map side joins in the videos, in the paid videos, right? So if you talk about the map side join, so when a join is performed on the mapper, it is called as map side join, and if it is performed by the reducer, it is called as reduce side join. Okay, so in this type, the join is performed before the data is actually consumed by the map function, whereas it is not required, it is not the case of we'll talk about reducers right now. Okay, so it is mandatory that the input to each map is in the form of partition and is in sorted order. Okay, and there must be equal number of partitions, it must be sorted by the join key. So we have talked in detail about this stuff in the map side joins in advanced map reduce. Now if I talk about the reduce side join here, so when a join is performed by the reducer, it is called as reduce side join. There is no necessity in join to have a data set in the structured format. So map side processing emits join key and corresponding tuples of both. So you can for now you just leave these all lines apart. I'll just tell you here. Okay, hold on, what a join is. Right. Okay, let's say I have two data sets, abc.txt and xyz.txt. And this is my xyz.txt, and it has certain columns, let's say ID, roll number. Okay, and this is your ID and class, for example. So the very first thing, this is a dataset which has the student details. Alright, and this is the class details. Fine. So they have a common field here, which is ID here. So ID is a common field here, if you see that. So ID is a common field, so you can join these two data sets and form another data set based on that, wherein you can have all the fields. Maybe you can say I want the ID, okay, plus class details plus roll number, and let's say name also. So let's say this student dataset has name along with your roll number and ID. So they'll perform the join on the basis of common column or common field, and we can get a third output here. Okay, so they both can be joined to form a third data set here, right? So what do you mean by reducer join? So actually this whole stuff is being done by the reducer now. So either the mapper could do that stuff or reducer can do the stuff. Okay, so if this joining part is done by the reducer itself, then it is called as reducer join, and if it is done by the mapper, it is called as map side joins. Okay, so the data set that we'll be working upon here is, I'll just take you through the data set here. Right, so this is a data set that I have. One is a customers data set and one is transactions data set. So in the customer data set, I have the customer ID along with the name, and then I have his or her age plus his profession. So this is a customers data set that is available with me. In the transactions data set, I have the transaction ID, on which date the transaction was performed, plus the ID who performed it and how many rupees or dollars he spent, and what was the type of activity that he spent money upon or transaction was carried upon. Okay, so here we need to see, right? So what we'll be taking out of this stuff is, if you see carefully, so there is a column which is common to both, that is customer ID. So 4 penta 5. Okay, and similarly 4 penta 5 here as well. So these are this is the column only which is common to both of them, so we can perform a join on the basis of this column, right? So this column, these two transactions can be, or data can be joined on the basis of the column which is a customer ID. So what we will be requiring here is, so we will tell that, hold on, so this is my two data sets, okay. The one is customer and the other one is transactions, okay. So I'll join them to form a third data set which will have following fields. That is, it will have name of the customer, plus it will have the count, how many times that customer has performed the transaction, plus the total money that he spent. Alright, so based on this ID, we'll count the number of times it has occurred in the other dataset, and we'll also take out the values, or the money spent that he spent on that transactions, and we'll sum that value and we'll count the values and we'll give the name corresponding to that values. Alright, okay, so let's start with our hands-on part. You'll be able to get it more clearly then, and when the output is produced, you'll be crystal clear on this stuff. Okay, so this is the dataset that is available with us. So I'll go to my virtual machine, and I'm already in virtual machine. So I'll create a new package here. I'm gonna name it as com.joins. Oh, hold on, it's not printing. So joins dataset is package is created successfully. I'll add a new class here. I'm gonna name it as joins reduce. I'll add the main method as well. Click on finish. So my joins reduce class is created now. Okay, so I'm using the same distributed cache one because I need not have to add the libraries again and again. So you always take care when you're doing something on your Hadoop, you need to import the Hadoop common and Hadoop map reduce client core. So this may vary because I'm using 5.4.2 CDH, that is cloud era version. So based on the version that you have, this can vary. Alright, so here we go. And now, so this class needs to okay, so this is my join reduce class, a simple class I'm gonna write here. Now I need to have two mappers inside this class, the one for the customer data set and the other one for the transaction data set. Okay, so from the customer data set will fetch few fields, and from the transaction data set will fetch few fields, and the reducer will join all of them and will give us the desired results. What all we want to print in the output, it will let us print that. Alright, so for that I'll just write here, I'm gonna make the concept of inner classes, that is class inside the class. So for that you need to declare the class as static. So public static class, okay, I'm gonna write it as cust mapper. Alright, and it's gonna extend the mapper class. So mapper class is here. Okay, so now you need to mention that what type of data set or the data type should be there of your key in and value in, that is the input to the mapper should be of what kind and the output of the mapper should be of what kind. So my input key should here be of object, and this is my text. Alright, this is again text, and this too is text here. So based on the requirement you need to check what all you're passing here. So I'll add this. Okay, so I have customers mapper, extends mapper, object this. Now I need to override the map method of mapper class. So I'll write here map, press Ctrl space. Okay, so this is the overridden method. I'll just comment this part, I don't require this super.map, else it will execute the or call the method which is of super class. I'll mention my own stuff here or the logic. So I write here string. Okay, So here my key is passed and this is my value. Okay, so I'll write here string records is equal to, I'll convert the value to string. So as the value is of type text, I'm gonna convert it to string. So if you see here, the values that is coming is of type text and I'm converting it to string. This is because text is a data type of Hadoop, and the Java doesn't understand that. So you interact with Java, you need to convert it into string and then proceed further. Alright, then I'm going to declare an array of type string. Okay, I'm going to name it as parts and I'll say record dot split, records dot split. So here if you see carefully, this is a comma separated value that we have in our data set. It's a comma separated value. So I want to split the each record on the basis of comma. So when you whenever you give a a text file to mapper, you will give input as byte offset value along with your key, complete line. So here the line we are getting is of type text, and we need to fetch or we need to get the words out of that line. Alright, and if you see carefully, this is a comma separated value. Each field is separated by a comma here. Moreover, in the customers transactions as well, so each field is separated by a comma, so we will be separating it with a comma. Alright, okay, now okay, so we have written this. Now we need to write the output of this mapper class. Okay, so I write context.write. I'll declare new text. From this, what do I want from the customers data set? I want the transaction ID, the customer ID plus the name of the customer. So this is the 0th location in the array and this is at the first location in the array. So right here 0th, and inside that parts 0. So I'm converting it back to your text type. Okay, similarly this one, new new text. Okay, and I write here customers \t plus. Okay, so I write here parts 1. So these are the two fields only that we require, right? At the 0th location I have a customer and the first location I have the customer name. Okay, so our customers mapper is completed successfully or written successfully. Now we need to move on with the transaction mapper. So I'll write the similar lines: public static class and transactions mapper extend mapper. Okay, and key in, you need to define it again. So it is similar to the one that we did previously. Object text, this is also text, and here goes text again, right? So it's public, not publics. Alright, now we need to override the method. So let have map. So this is the overridden method. I'll just comment this portion. I don't require this. Okay, now why is it still there? Okay, yes, it's gone. Okay, now I write the logic for transaction mapper as well. So I write here, I'll declare a member variable records again is equal to value dot toString. Okay, same funda, because we are getting a value which is of text format, we need to convert it into strings. Okay, so that's why we are changing it to toString. We are using a function toString here, and other one will declare a array again of string data type, I'm gonna name it as parts again, and records dot split on the basis of comma again, right? And now what do we want from transactions? Okay, so what is that? So from transaction dataset I want new text. Okay, what do I want? I want the field which is on second index, that is, let me take you to the, okay, so this is my 0th, 1st and 2nd index, right? So this is, I want this customer ID along with the count, oh sorry, the amount that he or she spent, or this customer ID spent. So I'll be taking 2nd and 3rd here in my output of the mapper, right? And right here new text, right here transactions \t plus, you write here parts 3. Okay, so this is the stuff for our transaction mapper, and this is for our customer mapper. So for rest of the code, that is for reduce join, that is reducer logic, plus our main method, that is configuration of the job, we'll be doing in the second part of this video. Alright, so I'll take you through that. Okay, so you'll have to go back again to this section, advanced map reduce, and you have to click on this video or this link to get the second video. Alright, so you'll be able to see that. Alright.